Ladies and gentlemen, welcome to the lecture on user interface engineering, and today is the last chapter, chapter 8, from software to usability engineering. Since it is the last lecture, I would like to briefly look back. After an introduction into the course and into some theoretical terms, introducing them, I immediately went to the scenario-based development method. And I talked about requirement analysis, about the design phases and usability evaluation. And before the design phases, I introduced you to sketching and prototyping as a very important pillar accompanying all different phases. Actually, I would have liked to introduce you to this lecture I'm going to teach today before I talk about the scenario-based design method. So in former times, we even had this lecture at this very point. That means we introduced you to this historical development wherefrom did usability engineering actually emerge. And only then we introduced the scenario-based design method as one particular variant which we dealt with in the entire lecture. Unfortunately, this was not very practical for your exercises and for your coursework, because then only somewhere shortly before Christmas you would have been taught some content about the design phases, which was certainly too late. So therefore we moved this entire lecture to the end, and but you can see it as a recap as well, and logically, however, it somehow fits at the beginning, and you can see that as a development basically, which then leads to the actual scenario-based design method we were dealing with. So today, in today's lecture, I would like to give you a short historical overview on software engineering and software engineering lifecycle models, because this was really the basis where all the usability engineering efforts started. And then I talk about usability engineering and the three components which are important for the development of that field. And then I talk a little bit about usability engineering methods, to give an overview and to compare some of them to you, and I talk about user-centered design as a further development. So let's start with some historical treatment, the history of software engineering lifecycle models. You must imagine in the 1960s, hardware and software were always bundled. That means the software came with the hardware, and the development was really complicated. So a lot of manpower went into the development of such complex systems, and from that a variety of challenges were arising. The complex systems were really too big to be manageable, to be honest, and therefore there were a lot of failure resulting from that, like too much money spent on the development, a very late delivery, ineffective and unreliable system, and this led to a software crisis back in the 1960s. Remember, this was a time where there was no PC yet. It was mainframe computing, and IBM machines, for example, mainframes were bundled with software. And there was a very nice development. So in 1968, there was a workshop first, and later on a conference on software engineering, which took part in Garmisch, and it was called a NATO workshop. And this NATO workshop is like the birth of the modern software engineering and the emergence of software engineering as a professional discipline. So the term software engineering at the beginning was rather meant to be provocative, to be honest, because is it really about engineering? And the idea was to apply more structured and systematic ways to the development of such big, notoriously big and complex software systems. So to be able to tame them, basically, to be able to develop them in an appropriate way. This was a very important thing. This workshop was led by Peter Nau and Brian Randall, important figures back then, and also a German researcher, Breu, was participating. All these are figures in software engineering with a big influence. And the software engineering, the term, was founded on the ideas of structured programming. And this was later published by Mills in 1971. So the idea is really to break it down, a software system, into substructures. This might include some database systems, so to have access to the data. This might include some event handling, say if some terminal input has to be processed, etc. So the major structures had to be identified, and solutions had to be found for each of these structures. So the idea was really to again gain control over the design activities by making the software development process explicit and systematic. And this was here you see a picture of the participants here, a group picture back then, and this was truly an important endeavor, basically, yeah. And the NATO Science Committee was sponsoring that workshop, and there was another one the year after, and this was really the birth of software engineering as we know it. And one of the results emerging from that was the waterfall model, which was introduced by Winston Royce in 1970, and it's very early and influential model because it tries to not just break the system itself into its constituent parts, but also to break down the development process into several activities. And this was these activities, the requirement phase, basically, we would say phase today, consists of the analysis and then the specification of the software system. So what does it need to fulfill? And then there's a design phase and the implementation phase, the testing and verification, and then of course deployment, integration, and maintenance later on. And all these steps are gone through in a rather sequential way, modular phases. And each phase is only started when the previous is finished. So only when you have written the specifications, so what the functionality of the system should be, only then you design the software structure and the software artifacts themselves. And they produce one or more documents which are handed off as a specification for the next and following phase. And this is a very good approach for the management because it has a very organized, traceable and measurable procedure. And you see the progress and you can measure the progress and also plan the progress through these phases. But of course, and that's the most important weakness, a system can't be anticipated entirely. The development of a system can't be anticipated at the beginning. And always the requirements change. It's like with everything in life, you have some ideas at the beginning and then you notice, oh, I have to do this or that, we have this requirements. Even if you book some holidays, for example, your requirements or your ideas of how to do your holidays and spend your holidays change over time. And this, of course, the more applies to software engineering, where the client typically, as you remember from our requirement analysis lecture, the client obviously often does not even really know what they want to have and what a system should actually deliver and accomplish. So the requirement analysis should not just be at the beginning, but should be repeated or should be revisited later on. That's very important. And also testing and iteration are required to a certain degree in software development. That means the idea to only test the system after it was finally implemented is a bad one, because already earlier in the design and early implementation phases, of course, you might face problems and then you have to go back to that. So iteration was not built in this waterfall model because it's just going down, but it was influential. And in 1987, Fred Brooks, another important person, wrote a groundbreaking paper which was called No Silver Bullet, or No Silver Bullet. And this was a paper in IEEE Computer, and later on also a book, which was cited over 5,500 times until now. And he was reflecting a little bit about the software engineering itself, about that you have not just accidental complexity, but also essential complexity in a software system. What does it mean? Accidental complexity is one which is introduced by, for example, errors you do in the planning or in the structure of how a component talks to another component, or a software part, so a software piece, like there are problems maybe in the interface between different constituents of a software system. So this is accidental complexity which could be removed. But he also figured out that there is something like essential complexity, and this has to do with the entire process, how we design software. That was his idea, and he said that this essential complexity can only be tackled and an improvement made. That means to make software more successful, basically, and more performant, and to bring it forward when we tackle essential complexity. So basically he compared the software engineering with the hardware engineering. And in hardware we had this increase of like 2 times faster or 2 times more performant in every year or every 2 years, depending on how you measure that in a short time. Whereas in software engineering we didn't have this gain. Basically we don't have this gain of performance and also speed and accuracy. And he said we can only deal with that when we do introduce incremental development. That was the idea, basically. That means incremental development should be built in, and this planning never leads to a successful and dynamic or a product which can dynamically react on changes. So iterative development, this term, basically he stressed and emphasized that, and so even though he said at the end there's no silver bullet, he said, so that means there's no single solution which is ideal. However, he's concluded by addressing essential complexity we are able to move forward, and that's very crucial and has been often discussed. Crucial for the entire development, not just of software, but also for, of course, the interface part of software we were talking about in this lecture. So prototyping and iterative development are crucial activities, and it's a complement to any structured development method to prototype. That's what we already talked about. A prototype implements ideas that are abstract, they are made visible, concrete, touchable, testable, and we can even do user studies with early prototypes, as we found out, and can be built at many phases, almost at any phase of any software and, of course, user interface development process. So, of course, if things, and this is a trade-off, if things are constantly changing and you don't have a very clear structure or a very structured process, this might undermine the integrity of software design. However, prototyping encourages iteration in software development and may lead to inefficiency or local optimization of the software on the downside, because you might have tried this particular part of the software or the interface, and this is now well developed where other parts are neglected. That's maybe a disadvantage. We talked about prototyping already as a requirement analysis method, so you can even build prototypes as trial versions of the software, test them or discuss them with your clients, and then derive better or improved requirements. In iterative development, design documents are produced as an output of each phase, and that also applies to software engineering, not just to usability engineering, and they are continually modified through prototyping and testing, and they describe at the end the system that was built in its final version. Let's come back to the software engineering model. So we already talked about the waterfall model. And Barry Boehm in 1980 introduced another important model, picking up this idea of iterative development, which Fred Brooks later on postulated again in his No Silver Bullet article. It involves the spiral model, future users, or at least future stakeholders, and in particular regular feedback throughout the iterative development. So therefore, prototypes play an important role and smooth transitions between all the phases. So to, at the end, come up and arrive there with less surprises. So this is not really the original Boehm's spiral model. It's just the general idea of that these typical phases like analysis, design, implementation and testing are interleaved and they are in an iterative fashion. So the spiral model by Boehm looks like that. It is the idea as opposed to the waterfall model. I mean, the waterfall model has several disadvantages, as we talked about. One obviously is the strict order, which is here now spiral and iterative. And a second one is that the waterfall model does not consider risk analysis, for example, and it does not consider user involvement. So users do not play a role in the waterfall model, nor does the analysis and treatment of risks play a role. This is different here, and you have, of course, objectives you're determined in a requirement, and you start then, you continue with risk analysis. You have soon developing your first prototypes. You develop, that's what you do here, you develop them, you test them, and then you plan the next iteration. So you have a concept of operation. So it goes on, and it's always you analyze what risks are involved. It's a little bit like with the trade-off analysis, but here more in a software engineering manner. You develop, you have your first prototype, then again you further develop it, you verify it, you validate whether you met your goals, and then you continue with your development plan. And this goes on like that. So you have a spiral, and that's a very interesting model because it really helps you to advance in a very structured way your software engineering model and your prototypes basically. So important features as opposed to waterfall model is risk analysis, prototyping, iterative development, and it also explicitly encourages considering alternatives. That's very important, and that's what we can learn from as well for usability engineering later on. So it's very good for large and complex projects, but not for simple ones because it's an overkill basically. You wouldn't do a risk analysis if you just do a small software development. Later on, another model I would like to mention here is the V model or V plus model by Kevin Forsberg and Hal Moose, introduced or developed in a longer period of time, starting around the time of the Silver Bullet paper, so in 1987 to 2005. And it's basically an extension of the waterfall model, but it stresses the aspect of decomposition. And of course, it also has incremental development and also incremental delivery. So this is the time axis basically, and this is a project definition. You start with the concept of operation, you develop, so you come up with a requirement analysis, you develop the architecture, and then you go into more and more detailed design until you implemented your system. And then on the other side of the V, you go up. This is a project test integration. So you test it, you verify it, you integrate it, you validate that the system as a whole works and that it can be integrated into its environment, maybe a certain company or structure, and is maintained later on. That means, in other words, let's look at on the right hand side. You see that better here. So we start from requirement analysis and system design to the concrete software architecture, to the design of each individual module, and to then coding it. And then we have, first of all, unit testing. This is a low-level software testing on software modules. Then you test the integration of these models into an entire system. You test then the entire system itself, and then you integrate it and, for example, test its acceptance, maybe in a company or in a bigger context. And you see these test phases are built in here in between, and it's an interesting process which particularly stresses incremental delivery of software, and also which of course includes a documentation which is handed over from each phase to the next one. And it also demonstrates the relationship between each phase and its associated phase of testing. That means this is the phase and this is a testing phase which is always associated with one of these phases. That's the idea of the V model, which is also quite, or has been quite successful and applied a lot. Yeah, so all these software engineering models are systematic, they are quantifiable, there are structured approaches, and they are basically addressing and maintaining large software systems. And what unites them are the typical phases in each software development process, which are requirement analysis or analysis phase, specification of a system, its design, the implementation, testing, integration, deployment, maintenance, and support. So these are the typical phases which always appear in any software engineering cycle, basically. And later on, to overcome the disadvantages, such as the disadvantages of the waterfall model or even the V model as we have seen now, some more agile methods were developed to better able to respond to changes. So we talk about that a little bit later. That means any of these models, be it the spiral model or the V model, also have disadvantages, not just the waterfall model, and therefore a more agile development where you can react on changes in the requirements and on changes in the situation and dynamics is more appropriate. So software engineering has of course drawbacks if you look at it from a user interface perspective. That's very important. By now I was just talking about software engineering, and I would now like to make my point why we have to arrive at some user interface or usability engineer. Because software engineering itself does only focus on the functional requirements of software. That means which functionality is available. Is there, say, a function to book a ticket? Is there a connection to a database where all the customers are stored? But this is not, a customer is not in a ticket reservation system. A customer is not considered to be a person who is interacting with the system, but a customer is just considered to be a data record, a data set as part of a database in this ticket reservation system. And that's a difference. So it often loses sight of the actual user of a system. And another thing is that, of course, a software system had always, in the past 30 years or so, an interface component, or quite often. But this development of the interface was rarely done by experts for that, and in particular not by interdisciplinary experts. That means no time, budget, or knowledge were available for developing or using novel user interface concepts. And that was a serious disadvantage, and in particular when the software engineering was further developed so that there was not much difference between the algorithms in some parts, then of course the interface played a more crucial role for the success of a software product in general. And therefore we had to focus our attention on that again. So the goal should be human-centered software engineering. And therefore I would like to sketch the development towards usability engineering now. So in the 1970s, the users became more diverse and less technical, in particular, of course, in the 1980s with the advent of the personal computer. But certainly the needs and preferences of end users were more in the focus, which of course had to do with the fact that interfaces became more user-oriented and manageable. So it was not just for the few experts who were able to operate a command line interface, but increasingly these interfaces were more widespread and were used by more people because the number of computers also increased. In particular, in the beginning of the 1980s when the personal computer was introduced. And interactive systems could then be compared and evaluated with respect to their usability. That means the usable quality of a system, usability quality of a system included ease of learning, ease of use, and the user satisfaction. These are the three components: ease of learning, ease of use, and the user satisfaction associated with an interface. And three perspectives have contributed to what we now consider a modern view of usability and usability engineering. And three developments, these are the human performance, so to have a better look on how humans perform. In the second phase, to focus on learning and cognition, so that means to include knowledge about how we actually think and perceive and learn. And then third, that interaction with the system is rarely just done alone in a single user way, but this is a collaborative activity, even stretching to collaboration maybe in your company or in a group of people in a team. So this includes cognitive and social aspects in the sense of distributed cognition, as we have already talked about. And of course, a novel, even more recent perspective I added here is the user experience, joy of use perspective, which stresses the emotional value of software. So not just is it easy to learn, is it easy to use, can I cope with it, is it effective, is it efficient, am I satisfied, but a little bit more, am I affected by that? Can I build a relation to my interface, like people have a relation with their smartphone, for example, which of course is maintained and is of course mediated by the user interface. So let's look at these three constituents of the development of usability engineering. Of course, first of all, the performance of human beings was tested. That means human factors included basically, actually there was not much knowledge at the beginning, but in the 1970s it gradually started that people thought about the performance of a system. So there was basically at this time no scientific basis for understanding usability. There were no empirical methods, at least not in the software engineering domain. Of course, in psychology there were already empirical methods, but no techniques which you could easily apply, so no knowledge about particular usability studies, for example, as we know them today. But the emphasis was on optimal performance. That means to have simpler displays and to have maybe fewer or better commands which are more effective, to achieve to achieve a goal with fewer keystrokes, or to have shorter execution times. So it was all about measurable outcomes. That means it was about performance, it was time, about error rates, about efficiency, basically. So this was the starting point where at least such things were developed, and where interfaces were, of course, because the mouse was not existent back then or not used commercially, that interfaces were optimized for keystrokes, and they were certainly not optimized for satisfaction or ease of use. But usability could be studied empirically, so they started developing methods how to measure, for example, task performance or errors, and it could play a role in software development. This is what the 1970s brought to us, to the community. Later on, when the first PCs arrived, suddenly more people had access to a computer. And the PC, especially the development of the Apple Macintosh, and first before the Apple Lisa, 1982, 83, 84, led to a consideration of human cognition about and the consideration of mental models or plans and actions. You remember some of our models we were talking about later on were developed in that in the 1980s. And of course, we talked about it not later on, but earlier on in the previous lectures. So we had compressed product development cycles, and we should therefore there was a need to improve the system's usability in an easy way. And things like inspection methods were developed during that times, which were based on guidelines or theory. So these are analytical evaluation methods we were talking about. And of course, also learning aspects came into play. So how people learn to solve problems with computers. So what is their approach, their cognitive approach, and what are their mental models? So the idea of metaphors were arising during that time, and how to apply them for human-computer interfaces. And a new area of shared interest between computer science and cognitive science evolved, which was back then coined human-computer interaction. So as a new discipline, subdiscipline of computer science, human-computer interaction arrived there as a term in the 1980s. And some of the significant early HCI projects were, for example, these goals, operators, methods, and selection rules modeled by Stuart Card, Murray, and Newell in 1983. We talked about that, and this advanced the human performance testing. But remember, humans performance testing was really not taken into account, am I satisfied with the system, but it was really about error rates, about task completion times, about the duration of keystrokes and how to sum them up to efficient interfaces. But also it was later on addressing mental activities that guide our behavior, and that was a new idea. So not just to have a stopwatch and sit there and say you need 20 seconds to fulfill a task, but also what mental activities are included. What happens when the user perceives something. You remember, for example, Norman's stages of action model, which is also an important contribution in that direction. So the prior knowledge of users also played a role, and the analogy to everyday objects and activities. So metaphors, as I said, were developed and considered during that time, and of course the famous concept of direct manipulation, also drag and drop, and all these principles which are crucial for our today's interfaces still, and of course for decades of the graphical user interface as such. So this was the second impact of human-computer interaction, and also it was the first time where the design activity itself was reflected on. So it was not just the product, but also how to develop. It's comparable a bit to software engineering, because it also took a while before the development processes, like we have learned with the waterfall and spiral and V model, have been developed. So it took a while until such structured processes were introduced. And the same was here the case for human-computer interaction. And methods which support such a process of continuous design have been introduced, such as a think aloud technique, for example, where users comment what they do while accomplishing a task, what they actually do, what they see, what they perceive. And that helped us, or the people back then, of course the researchers, to understand the mental activities of people and how their cognition together with computers basically worked. By the end of the 1980s, was usability no longer just assuring the quality of the finished systems, but instead it was a comprehensive process. That means it included activities such as think aloud evaluation and of course continuous prototyping from an interface perspective, not just from a software perspective where it was already introduced earlier. And of course, this user involvement or participatory design, to involve users in requirement analysis and in the design phases, has been developed back then. The third aspect contributed, especially in the 1990s, to the development of usability engineering. And this is to take into account that people are not isolated, and that people have a workplace, a context where they work, and of course that they collaborate and cooperate with other people. So the scope of usability was broadened to also incorporate social and organizational aspects of system development and use. For us now it's completely clear, and especially in the scenario-based development, we talked about that people have to consider, who develop a user interface, the task of the users themselves, as well as their context. But back then this was not the standard, but it is slowly developed in the 1990s. So we wanted to understand the activities of users in the real world, and this is not just a task analysis, because that has been done in software engineering already, but it's a detailed study of work practices or roles of people. They have maybe also in social means and roles they fulfill in a team, say at work or so. And so therefore the associated concepts were developed, such as field studies, how to conduct field studies in the human-computer interaction area. And the scenario-based development method is one of the approaches which were developed back then in the 1990s, as well as others we will talk about in a minute. And also there was a research interest in activity theory, so where technology is just one of many factors helping people to accomplish a certain activity in a given context. And of course later on it was also thought about how people work together by means of computers, either mediated by computer or using computers, maybe also in a distributed fashion. And the term computer-supportive collaborative work was developed, so computer-supported collaborative work, where basically this is like the origin of things like Google Doc we have today, or Share LaTeX or Overleaf, all these ways of collaboratively editing, say, a document or so. That has its origins back in the 1990s, where people first thought about that an interface is not just operated by a single person anymore. Yeah, and usability engineering, this term was already coined in 1986 by usability professionals from the DEC company, and measurable usability goals were identified, which should be defined early in software development. That was already mentioned back then, and then repeatedly assessed during the development to ensure that these usability goals are actually matched and reached. And right from the beginning, this was relying on user interaction scenarios. Initially, usability engineering focused on the design of the user interface. That means engineering effective, interactive presentation of information and the system's function. But now also other software development activities belong to that. That means requirement analysis, specification were taken into account. That means usability engineering became a part of the entire software development process and was integrated also into the earlier phases. So in the past 30 years or even more, usability has become a central focus in software development, and there was a survey already in 1992 which came to the conclusion that 50% of a system's software is already devoted to the user interface, to view, maybe to controlling the user interface, to reacting on interactions by users, events. That's quite a lot, and that of course clearly indicates that usability engineering or the interface engineering needs to be a part of the software engineering as well, and needs to have its own methods and processes. Non-functional requirements are anyway important for any software system, and usability, just to say that and to not overestimate and overrate it, is just one concern. It means usability is an important aspect of any non-functional requirement, but also project size, involvement of legacy systems, portability, reliability, maintainability, software economics. All these aspects are also non-functional requirements like usability. And of course, some of them are even in conflict with the goals of usability engineering, and that has to be considered. Just one example is legacy systems. So if you really have to consider legacy, then you arrive at some solutions such as that you have to press the start button in Windows to shut down a system. This is a typical example for legacy which had to be considered, and you could not easily design a system from scratch, looking to a better future of an interface. So that is always a problem if you have to consider such a legacy systems. Just to give you one of these examples where you have a conflict of the goals of usability engineering with other non-functional requirements. Let me talk about the third part of this lecture about usability engineering methods in particular, and also at the end about user-centered design. Because by now we learned that we need to have usability engineering as a crucial part of any development, but that it also needs its own methods and its own processes. What is usability? It's not the quality of a product, obviously, but it's a quality of how a product is actually used. So it's a quality of its usage. Usability in German is called Gebrauchstauglichkeit, is a measure on how a product can be used by certain users in a given context, in certain context of use, to achieve certain goals efficiently, effectively, and to the user's satisfaction. So this is a definition of ISO 9241, part 11. And you see a few important aspects here. So there are certain users. It's a context, so user, the context of use, which includes of course the environment and other people and the technology, etc., to achieve certain goals. And the goals are, of course, associated with tasks the users have to accomplish. And you see the quality itself, its efficiency, its effectiveness, and satisfaction. So its efficiency, its effectiveness, and its satisfaction. These are the three things which can be measured and which should be considered. Usability is the quality of an interactive computer system with respect to ease of learning, ease of use, and user satisfaction. That's what we have already talked about. And software ergonomy, this is also software ergonomics, an old term which was coined in Germany, obviously, and is the basis for such usability. So that very much like a hardware product, say a car or so has ergonomics to think about and to consider, and also software has to have ergonomic aspects, and therefore the term software ergonomy was invented to describe that. Usability can be achieved with systematic usability engineering. That's what we already talked about a few times. And the usability engineering process is also defined in an ISO norm, in the 13407. So very much like what is usability at all has been defined in an ISO norm, also the process has been defined. And this includes prototyping and the context of usage scenarios, as well as evaluation. And so the product itself is defined in this 9241 ISO standard. So the quality of the product, the usability engineering, what should it arrive at, and so the design elements, the user guidance, how to design dialogues, how to fulfill multimedia requirements, all that is described in the ISO process. I do not talk much about this ISO norm because it's a little bit old-fashioned already, but I come to that in a minute. Usability engineering results from an intersection of software engineering with human-computer interaction. That's for sure. So we talked about that these methods, such as the GOMS method, or such as stages of action model by Norman, or Fitts law, etc. These are all methods of human-computer interaction, and if you combine them and intersect them with software engineering approaches, like the structured development in certain phases, you arrive at usability engineering. So it helps integrating human-computer interaction requirements and design approaches within development projects which are managed by software engineering methodologies. In other words, usability engineering is a structured approach to developing usable user interfaces and designs. There are several methodologies for usability engineering which help developers with certain techniques, steps, methods, phases for integrating user-centered development throughout traditional software engineering life cycles. And they need to be highly iterative, that's very important, and of course based on a solid foundation of requirements. What usability engineering processes are existing? Actually, there are several ones. For example, one by Jacob Nielsen from 1994. There is the ISO usability development process, which is described in the standard 13407 and was standardized in 1999. Deborah Mayhew wrote a very nice book. This one here, the Usability Engineering Lifecycle in 1999. It's a thick book and describes her process and her approach of usability engineering as a life cycle. Then we have the one by Mary Beth Rossen and John Carroll in 2002, the scenario-based development method, the book where big parts of the lecture are based on. Then we have by Helen Rogers and by Jenny Priest and Yvonne Rogers, Helen Sharp and Jenny Priest, sorry for that. The interaction design, this book here, which has already, I think it's 6 editions, so this is just a copy of the 2nd edition as you see here, but they all look a little bit similar. They are of course updated. This is a very, very successful book of these 3 women, and it's, I think, my most beloved book in human-computer interaction. It has a fresh approach, and I can only recommend that to you, and I think I use it also throughout the lecture repeatedly. Just to say it again, Yvonne Rogers, Helen Sharp and Jenny Priest. And then there's a more recent methodology by Knapp et al. We come to that in a minute. And the ones with this magenta numbers here, I will be introducing on the next slide. So I already, by the way, I already briefly introduced the ISO norm, obviously, on the previous slides, and I will continue with the other ones in a minute. Just to say it again, what unites all these usability engineering approaches as opposed to traditional software engineering? There is certainly not a focus on the functionality, but on the users and their tasks. And the emphasis on context. So this is what all this scenario-based development is about, and I think this nicely wraps up the entire, summarizes the entire lecture. 3 essentials we already talked about a couple of times, and I only repeat them for examination, because this is the typical question for any examination. Are the users, the focus on users, on the context, and on their tasks. So users can, for example, be described with the help of personas. We talked about this concept, about these imaginary but precise and specific stereotypes. The context can, of course, be described, for example, with artifact analysis, and it serves the preparation of requirement analysis phase. And it can be an episodic description of users' working tasks in the language of the user, for example, and these are the typical scenarios we know. So scenario descriptions are the method to go for to derive and describe the context. And then, of course, task analysis, we talked about that in detail, contextual task analysis, task scenarios, of course, and also hierarchical task analysis as one more formal method to arrive at a good description of which tasks need to be accomplished by users of a future system. So it also focuses on human information processing limitations and work models. And of course, we should rather design for goals a human being is trying to accomplish than tasks. So tasks might change. Tasks are rather low level and detailed, and the goal is a little bit bigger. Like, I won't like to borrow a book. We had this example, and the particular task, like I have to go to the library or not, they might change. For example, in Corona times, you suddenly can't go to the library, so you have to change your particular task, but the goal still remains the same. So let's go again back to the different processes, and again, this ISO 13407 is quite straightforward. It's a user-centered software development process. So we start with an understanding and specification of the context of use with task, users, and the environment. Then we derive from that usage requirements. We develop design solutions, so this is a prototype, and then we evaluate the design. So this is a rather simple model, and of course it's an iterative model as well. More elaborate is the Usability Engineering Lifecycle by Deborah Mayhew. It's a process model for usability engineering. And the phases, I already talked about that earlier in an earlier lecture, are quite similar to the ones of the scenario-based design method we were talking about in this lecture. So there is a requirement analysis where you have user profiles, you have a contextual task analysis, you think about constraints a platform is introducing, and then you arrive at usability goals, which are described in a style guide, and this is a document which is handed over to the next phase, the design phase. This is a yellow part. And the design phase is split into 3 different levels, level 1, 2, and 3. So this is a conceptual model design, this is a screen design, and this is a detailed user interface design. I don't want to go into every detail here of these parts, but the conceptual model design is comparable to the activity design in a way. The screen design is comparable to the information design we talked about. And then, of course, the detailed design involves everything. That means also the interaction, and therefore our interaction design is comparable to that. At the end, you have not scenarios as a document, but style guides. So Deborah Mayo is introducing style guides as the resulting documents of each phase here. And then, of course, there's some installation here, and then you seem to be done when you have resolved all issues. And it's iterative. You see that with this question, is all functionality addressed, sufficiently addressed? No, then you have to go back, etc. So you always have these feedback loops and iteration. This is just another depiction of which is in black and white. It's a bit better rendered in the graphic quality, and you see all these questions at the end of each phase. Were my usability goals met? Yes or no? And if no, I have to go back and maybe to redesign the system. That's the idea. And here you see the installation or deployment part, which also, of course, involves user feedback, maybe done by a summative evaluation at this point. So you might have a closer look to that model yourself. Important features are this holistic view of usability engineering by Deborah Mayo. It provides a link to software engineering approaches, that means in particular to object-oriented software engineering. It identifies stages which are, of course, requirement, design, evaluation, and prototyping as well. It can be scaled down for small projects, and it uses style guides as a major outcome of each phase and to capture a set of developing usability goals. So these are the characteristics of her usability engineering life cycle. The approach by Sharp, Priest, and Rogers, the interaction design approach, is a little bit simple. It's simpler as far as the process is concerned. That means this book, by the way, is of course also just an HCI, a basic HCI book, because it contains all these methods such as Fitts law or keystroke model, etc., which are HCI methods, personas, etc. And therefore, they do not spend so much time on a very detailed process like the one we have seen before, or like the scenario-based design method. So the process is quite simple here and comparable to the ISO norm. So you identify needs and establish requirements. That's the first part. Then you design, or later on, since it's iterative redesign, you build an interactive version. You might come back to the design activity. You might even need to go back to establishing requirements because you might have missed some important aspects. And then after you build an interactive version, a prototype first of all, you evaluate. You might need to go back to the requirements because you have missed something. You might need to go back to the design and redesign parts of your system. and at the end, after some evaluation, the final product arises. So this is a very realistic cycle. Basically, one can easily imagine that this could be a good development, and the user-centered design approach is therefore a good starting point also for you. It does not in particular look at documents such as style guides or such as scenarios from these two other usability engineering processes, but it provides, as I said in the book, a lot of methods which can be applied in each of these phases. In general, and of course, by the way, the fourth method, the scenario-based method, I think we already talked about a lot during this lecture, and I think in particular at the beginning of the second chapter, I was introducing this method in more detail. So the fourth, I refer you to the second chapter, the fourth method. All right, in general, user-centered design as opposed to system-centered design. This is what I would like to briefly talk about again. So system-centered design, what you for example have in software engineering, focuses on the aspect, what is it what I can easily build on this platform? What can I create from the available tools? What do I as a programmer find interesting? So it's really technology-centered and it's not user-centered. User-centered design, on the other hand, is based upon a user's abilities and real needs, about context, work and tasks. So it's about knowing the user, as you have seen here, know the user. And it's about the need for usable and useful products. That's very important. So user, task and context have to be known, and that's best done in a way incorporating the potential users and stakeholders. And that's what we call participatory design, with representative end users. So this is one way to achieve as user-centered design. And it involves, of course, constantly communicating throughout the whole process, and therefore you see that scenarios are very helpful because they are written in plain text and they are understandable by many stakeholders. So this is not a technical description, it's not a unified modeling language diagram, UML diagram, like in software engineering, but it's something what people can relate to. And of course, it's an iterative process. All design substages are subject to revision. I think I mentioned that quite a few times already. Let me at the end still talk about the Google Design Sprints, this method developed by Knapp et al. In 2016, because it also addresses a more agile way of development, and I promised that already twice to you. So basically, these Google Design Sprints are interested, so they are always concerned with a challenge, some sub-development which you can accomplish in a single week. And you first of all set the stage, that's the beginning basically. That means you assemble the right team, you gather the right team, which often is with 7 people. That's an idea, to limit it to 7 people and say there's one decider, so who chooses the design, which at the end has to be shown to the customer. There are customer experts, there are technical experts involved, and anyone who will bring a more disruptive perspective to the development. And then of course you also choose the time and the space where to conduct this sprint basically. And then we have the first phase. This is the unpack phase. On day 1 you focus on mapping this challenge basically and choose a sub-target or a target. That means something you can really achieve in a single week. And then you really start on day 2 with sketching competing solutions. So this is deliberately focusing on sketching alternatives, on generating solutions. And it's an emphasis on individual creativity and rather than group brainstorming at this phase on day 2 basically. And day 3, where you decide on the best solution, is focused on critiquing. That's the idea. So you have a critique, a design critique on the solutions which you generated on day 1 already. So the main part. And you choose one which is most likely to meet the challenge you have set yourself for this design sprint. And you produce a storyboard on day 3. And so the decider, this person of this team, chooses a solution at the end, and this needs to be supported then. And then, of course, on day 4, you have to build a prototype, a realistic prototype. So you have to turn this storyboard into a realistic prototype which can be tested. And this is, of course, something where then, of course, customers can provide feedback and they can use it and see it. And the test is done on day 5 with the target customers. It's about getting feedback from them. Ideally, you use at least 5 customers, and you learn from their you learn from their interactions with that prototype, and then, of course, from their reactions and feedback. And you see that this is again an iterative process, so you can do that several times. So this is just a more recent usability engineering life cycle from Knapp et al., which is like an agile software engineering used for a more agile development and not having these long phases like with the earlier design methods. Alright, so let me summarize this chapter from software to usability engineering. I think we know that usability engineering is now an established part of the software engineering process. We have seen also the development from software engineering to usability engineering. And that the user-centered design process is developed to have an easy-to-use software, of course, at the end of the day, and that there are 3 principles involved. So it's the early focus on users, tasks, and context. Obviously, this is one important part, that we have empirical measurements using quantifiable and measurable usability criteria. So we have methods to test actually what we came up with, and then this all is an iterative design. So also benefits of usability engineering are that this is a very pragmatic approach, because due to this iterative development, and especially if you have such fast-paced methods like this design sprints, you will arrive at some pragmatic solution. Of course, there are also drawbacks. For example, if you follow this ISO standard approach and the principles outlined there, then you see that they are a little bit outdated, what I already said. That means they are only focusing on single working places and in offices. So, for example, the DIN ISO 9241 says it's about ergonomic requirements for office work with visual display terminals, so Bildschirmarbeitsplätze. And this, of course, is a little bit old-fashioned, because we do not just have office work in our days, and we do not have visual display terminals, so it's a bit outdated. And also the DIN ISO 9241 reflects on ergonomics of human-system interaction, human-centered design for interactive system. So you can see that, but it's not focusing on, say, natural user interfaces. It's not focusing on gestural interaction in the wild. It's not focusing on augmented reality solutions, on even not focusing on mobile phone usage, say playing a collaborative game out there in the wild. So The creative development part in particular is not addressed by these methods. They are really focusing on efficiency, on effectiveness, and on satisfaction, but it's not about the creative development. And the joy of use in particular, or emotional values, do not play a role, which are of course a focus of what we now call user experience design. So this is something which has to be brought into the engineering as well, and to leave a little bit this strict, formal and defined by norms process. That means to bring in emotional quality and user experience is very important, especially in these days where interfaces are of increasing importance. Just to repeat it again, there are so many possibilities, like how to book a travel, or how to maybe shop online or whatever, and all these, or how to watch a video and maybe in a video streaming service. And of course, beside the content, the interface matters a lot for which product basically you decide yourself. So therefore also the experience value plays a very important role. So this is maybe a final statement to think about these emotional qualities of an interface as well. So to conclude, in this lecture you learned something about software engineering lifecycle models and the development of software engineering, and that they are limited with regard to how to consider users. And we learned about how usability engineering evolved from different perspectives, and that it produced appropriate models like about cognition and models like activity theory, about how we behave and operate an interface in social and in a work context. And then you learned some examples for methods for usability engineering. We briefly talked about 4 different approaches here, and then what is essential for user-centered design, which are users, task, and context. So with that, I'm done with the lecture. And also this is the last lecture for the entire series here. And here are a few questions for you to learn a bit and to prepare your examinations. We have references here to the literature as usual. And with that, I would like to thank you for your attention, for listening to these videos. Not every video was ideal, I know that, and it's always hard, and you have to think about my context as well, about the user, task, and context. So my tasks are quite manifold in these times, especially in these Corona times. And yeah, as a user, so as one who does this lecture, of course I'm in different moods. Sometimes I'm ill, or I'm tired, or overwhelmed by work, or I have to think about my 3 kids in homeschooling whatsoever. So there are many reasons why I'm not maybe 100% with you in this lecture, but I tried hard to do that. And of course the context altogether plays an important role as well, like how is the mood, the current mood, the situation in our society in lockdown times, for example, and that of course matters for such a video. And I'm really looking forward to seeing you in some presence lecture in the future again, and perhaps in the lecture on advanced user interface engineering, advanced user interfaces, AUI, in summer term, or interactive information visualization. So stay healthy, have a good time. I wish you good luck for your examination, and see you around, hopefully in presence, in the near future. Bye bye.